going to start here, but let's do questions first if I feel like it. And anytime I want to stop, I will. So let's see. I think they're on here. All right. Morgan, you said you had a question first, then Michelle. Number 9? There it is. Number 9. You're supposed to find a polynomial of degree 5 that has those as following zeros. Yep. All right. To do that, what? Oh, yeah. Are we supposed to multiply these out or leave them as factors?
Well, you put them in factors and then multiply.
Leave them as linear factors and quadratic factors, right? Okay. So this is x. This is x minus negative 2i. That's the 0 part. That's negative 2i. The conjugate would be x minus a positive 2i. That'd be the conjugate.
Oh, yeah, you would conjugate that too.
Yeah, and then the conjugate of x minus 1 minus I. And then x minus 1 plus I. Okay? And now you just have to multiply those two together and these two together, and that's it. Because you can leave it as a product of linear factors and quadratic factors. So on this one, the first fort will be x squared. Some people can look at it and tell. Some people have to take their time. Minus x 2xi, sorry, plus 2xi. That's the third term from this product. And then plus, 2i times negative 2i would be minus 4i squared, right? Right, it'll turn into plus 4. Then the second one will be x squared. Oh, missed. X squared. Then negative x times 1 plus I. And then negative x times 1 minus I. And the last but not least, plus 1 minus I, 1 plus I. There we go, at the end of the fort. That's not too difficult. Those cross off. That becomes a plus 1 or minus 1. So x squared plus 4 for the first one. That's a quadratic factor. That's power 2. And it looks like I'm going to need one more step here. X squared minus xi minus x plus xi plus 1 minus I squared. Yeah, there we go. That turns into negative 1, so plus 2. Those quadratics like that, they cause what? Yeah, because you factor it in terms of quadratics, that's what these are, a quadratic. And you factor it in terms of a linear polynomial. Okay? So that's a good question. Michelle? Okay. There's lots you can do for that one. I don't know. What are you supposed to do? Solve it?
Well, I made the find all solutions of it.
All right, find all solutions.
Like I did the fractional retest or whatever, and then I was going to graph it, but I couldn't.
Okay. The rational root test. If I'm looking for all solutions, plus or minus goes out in front. 1, 3, 9, 27. All those factors. Divide by all the factors of 8, which are 1, 2, 4, and 8. All right. Next, let me get my calculator booted up. I love that thing. I don't have to worry about if my calculator's in my bag or not. Oh, never mind. Remind me I got an announcement to make at the end of class. Administrative assistant, remind me. Okay. Y equals on the large screen 8x cubed 8x caret 3 plus 18x squared. plus 45x plus 27. All right. Let's see. Looks like I should go from, I can go all the way up to negative 27 and positive 27. Too big? I had never had that error message before. Oh, okay. Negative 27, 27. Y's, I could really care less about, but I usually just use negative 2 to 2, so I have a reference point. I don't want 54 tick marks, so I'm going to make them every 5. Why'd you pick 5? I don't know. You'll make it 4? Makes a difference to me. I just want 54 tick marks. That's a lot. There we go. Dun, 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 5, 10, 15, 20, 25, 30. Wait a minute. I thought I went to like 50. Oh, 27. All right, looks like there's something hanging around 0. So I'm just going to zoom in. Number 2. And I see my cursor is flashing at the origin. If I press enter, that's what it'll zoom in at. There's one. There. Huh? Well, I don't know. There's it's a cubic, so I'm guaranteed at least 1. Now, remember what this tick mark is right here? That's a 5, right? So I don't feel like guessing all those options. So I'm just going to go to second, calculate, 0, enter. And remember that tick mark I put at 5? So on the left bound, I'll just scroll back until I get to negative 5 on the X. So make sure I'm far enough away. You don't see the cursor. You don't have to. You just have to know that an X on the left side of it would be around negative 5. There you go. And what would be an X value on the right side of it? 5. You can scroll back on this calculator. I can just type it in. And my guess, somewhere in the middle, I get close to 0 when I scroll. So it's negative 0.75. Booyah. That's one of the answers, isn't it? Negative 3/4. That is a possibility. So I will take that negative 3/4 and I will put it on the shelf to do synthetic division. It said find all the answers, didn't it? Nice. No, we're not here about easy. We're here about effective. 0, 8. 8 times negative 3/4 is negative 6, isn't it? From my calculator. It said when x is negative 0.75, y is equal to 0. Did you type in the equation correctly?
Yeah, I just scrolled down.
You can't scroll. You actually have to do a calculation. Second, calculate 0. Yeah, or root. You pick a number to the left side of this. I picked negative 5. And then you pick a number to the right of it. And then you pick a number in the middle of it. So I picked negative 5. I picked 5. And then I picked 0 as my guess, somewhere in between. So now I have synthetic division. 12. 12 times that is negative 9. Add that, you get 36. Negative 27, and you get 0. Booyah! It's a winner. And what's the result of this going to be? Plus 36, right? So there's one of my answers. You have the quadratic program, don't you? So you can put in 8, 12, and 36, and what do you get? Yeah. So you get all that fun stuff right here. Oh no, it's 144 minus 32 times 36. I'm like, Mr. Shocked, I got all these windows open. 140, oh, I don't want this. Clear. 144 minus 4 times 8 times 36. Are they doing exact values in the, or are they doing decimals in the back? Square roots and stuff? Nice. I don't know, square root of 108, or I can divide it by 4, can't I? Nice. Can I divide that by 4 again? Nice. That's 2 4s. That's a 16. And that's a 9. Let's see. This negative will be an I. Bless you. Bless you. I got the 16. I got the 9. I got the 7. Right? Three times 4 is 12. This is a fun one. When I look up fun, I want to see this problem. Divide them both by what now? Oh yeah, square root of 7. What do I divide them both by now? What is it? 4? All right, so my answers are negative 3/4 and negative 3 plus or minus 3 square root of 7 I all over 4. What a great problem. Classic. Did you like that one? I like it too. Matt, glad you're here for that. Anyway, when you have a third cubic root right here, you can see there aren't going to be any positive answers. There aren't any sign changes. Based on the rule of sign, there are no sign changes. So there's no positives, only 2 complex, there has to be 1 negative. Yes? What? Sure. Negative 3/4 is the answer twice? It doesn't. It gives it to you like this. Negative 3/4, comma, negative 3/4 plus or minus 3 square root of 7 over 4I. And those are conjugates of each other. Non-real complex conjugate roots. That's a lot of math power words in one sentence. Who? Heat? No, I have no heat in this building. Not in my room. All right, ready? That whole no coach thing, that usually doesn't apply to my room. All right. I think we're about ready to move on, don't you? That was fun. And we got 10 for 10 today or tomorrow? Yeah, I know. I also have an announcement at the end.
You can just do it tomorrow.
We'll see. Here we go.
Good or bad?
Good. Find all the equations, find all the solutions to the equation. We're just doing like this. However, this is a 4th degree polynomial. How many answers are there going to be? 4 solutions. Looking ahead of it, did we do Descartes' rule of signs yet?
Yeah.
How many rule of signs are there? How many changes are there? So there's going to be 1 positive. You're guaranteed 1 positive X answer. If you change it to negatives, that'll stay the same. This will change. This will stay the same. This will change. How many sign changes are there now? 2. So you could have either 2 or 0 negative solutions, right? Either way, if you're going to the 4th order, wait a minute, that can't be right. Oh, I see the problem. Descartes' rule of signs doesn't work on this one. Not yet. What's one of the factors first? X. Now it works because you have to have a constant term for Descartes' rule of signs.
Write that down.
Yeah, you have to have a constant term for Descartes' rule of signs. Now there's going to be P in Z in C. What do you think Z stands for? 0. That has no sign. So there's 1, 0, 1 positive. If I change it, it'd be a negative 6x cubed plus 5x squared plus 17x minus 6. So the rule signs? Well, because this one, what's the answer for this one? 0. There's no chart for 0. But I need them to add up to 4. So 1 and 1 make 2. So I could have no negatives and 2 complex. Or I could have 2 negatives, 1, 0, and no complex. Either way, that's what my answers are going to look like. I'm guaranteed 1 positive answer. Okay? I'm not guaranteed any negatives. I'm guaranteed that one of my answers is going to be the number 0. And I could have 2 non-reals. What's the first order of business? What should we do first? Write down the 0 and hope for partial credit? 0. What's next? Does anybody know how to factor that in their head? 6x cubed plus 5x squared minus 17x minus 6? Well, now it's time to go to the calculator then. I don't know what you're waiting on. Punch it out. Let's go.
When in doubt.
Yeah. 6x cubed. 6x caret 3 plus 5x squared minus 17x minus 6. All right, I could go all the way up to, what's the factors of 6? 1, 2, 3, and 6, right? And same right there, 1, 2, 3, and 6. So I think I will just go from negative 6 to 6 and see what's up. Window, negative 6 to 6. I can go by ones, there's not that far. Negative 2 to 2. And graph it out. Oh, there's a, look at that. 1 positive, just like Renee said. Renee Descartes. We're on a first name basis. And there's 2 negatives. So according to Renee Descartes, this is my situation I'm working with. I just now have to find them. So, anybody got a guess for this first one over here on the left? Second, calculate value negative 2. It's a winner. Negative 2 is a winner. Any other guesses? Second, calculate value. Someone said 1.5. Hey, 3/2 works. I'm down to 1. If you want, you can do synthetic division now and find it that way. Or negative 1/3. Second, calculate value negative 1/3. There you go. It works. So that's the clean way of doing it. How do you know to guess 1/3? It comes from the factors of the constant divided by the factor. You know not to guess 1/4. You know not to guess 1/5. 1, 2, yeah, all the factors of 6. Remember the constant first, and then the leading coefficient in the denominator. Second, calculate. What did it give you? That's the same thing as 0? Right. Okay, that's the default way of saying 0. It's stuck in the intermediate value theorem, and that's the default way it kicks out. So that's equivalently 0. That was fun. That was easy. Nice. What time is it? We got plenty of time, don't we? Who? Oh, yeah, we're doing 10 for 10, aren't we? 7 minutes? All right. Let's see. What? All right, let's factor this one first, and then we'll stop, do a brain break, 10 for 10. All right? Find a factored form with, what's integer coefficients mean? Right. That means no fractions. Okay? Of the polynomials shown, assume everything is 1 to 1. I like this one. So we have to factor this. Negative 6x to the fifth plus 5x to the fourth, 14x cubed. All right, Colin, where do you think this number is right here? Negative 1. What's interesting at negative 1? Drew's not even paying attention. That's okay. Go ahead, Colin. So what kind of factors does that make it? Squared. There's 2 of our 5. All right, what do you think this one is right there? Go ahead. 1/3. Because it's tangent, like a parabola.
How do you know that?
It doesn't cross. If it doesn't cross, it's tangent. Okay. I go with 1/3 because look, there's a 1, a 3 right there, and a 1, 2, 3, and 6. That's clearly not a half. Well, that's not good. That's all right. That's okay. We'll keep going. How do you write 1/3? Answer. Who? 3x plus 1? I don't know. Most people just write x plus 1/3, but you take the denominator, put it in front of the x, so it'd be 3x minus 1. Now, is that to the first? Yeah, because it just crosses like a line. What do you think this one is right here? 1. That's pretty easy. X minus 1. Not too difficult. Uh-oh. What do you think that one is right there? 1.5, so it'd be 3 halves. So x minus 3 halves, but it says it has to have integer coefficients. So it'll be 2x minus 3. Does that add up to the fifth? Yep, 3x minus 1. So my answer would be all these that are in the top right here. Okay? X squared times 3x is 3x squared times the x is 3x cubed times the 2x is 6x to the fifth. We're in pretty good shape. Uh-oh. What do we have to change in our answer? What don't we have accounted for? The negative times 3x minus 1, x minus 1, 2x minus 3, and I'll just put negative out in front. There we are. Mr. Brooks, how are you? And we're done. Nice. Questions? All right, how far do we get? Like 20? Okay, so we'll do 27? We can do 27. You can do that one on your own. All right. So there's only like what? 21 to 27 odd?
Yeah.
On what page? What? 247. Good. Not everybody. Exactly. So we'll do that one. We'll finish up the section tomorrow. We'll do 10 for 10. We're going to do a brain break or not? Do we have enough time? Probably not. We'll probably just go straight 5 for 10. Yeah. Oh, you were here last week. Yeah. So what section is it from? 3.2? These are just zeros of a polynomial. Oh, I can shut this off. We don't need to record this.